So the first model was Arrhenius acids that donate a hydrogen ion, which is actually a proton, and Arrhenius bases that donate a hydroxide ion. So now we're just doing Bronsted-Lowry acids and bases, which is the same thing. We don't call it a hydrogen ion, but it's a proton donor. So it gives off a hydrogen ion, and the Bronsted-Lowry base takes a hydrogen ion, but we say proton acceptor. That's the convention. But they're the same things. So you can see that it's not giving off a hydroxide ion, but it is practically going to cause water to split up and hydrolyze the water by taking the hydrogen ions. Okay, so this is an example just showing you the Lewis structures. So the H plus comes off the water here, and then there's a dative coordinate bond formed. So it sticks to the free lone pair that's over here. All right, and you could have drawn this as a H3O ion. And so the conjugate, there's two conjugate acid-base pairs. The acid going to conjugate base is a conjugate acid-base pair, or the base going to conjugate acid is the conjugate acid-base pair. They don't say conjugate base-acid pair, they just say conjugate acid-base pair for both, even though one's a base going to an acid, one's an acid going to a base. And the only difference is, just be careful, is the only difference between these conjugate acid-base pairs is one hydrogen ion. So you can see the only difference between these two and these two is there's a H plus difference between the two, because you'll often get asked to identify the conjugate acid-base pair.